Hey, hello, welcome to the show. It's me, John Park, with a brand new microphone, and hopefully that's working. It's time for John Park's workshop, and thanks for joining. Also, thanks for putting up with my busted mic last week. Let me know in the comments, A, if it's working, and B, how the levels are. Looks like I'm somewhere around minus 6 dB. Maybe I'll goose that up just a little bit. Let's see. Tell me if that gets out of hand. What's happening here today? Thank you for joining over in the chats. We've got the YouTube chat and we've got the Discord chat. Those are our two main chats that we keep an eye on. So if you're somewhere else, such as Twitch, and you're wondering where the chat is, come on over to our Discord. It's at adafruit.it/Discord. And if you head there, you can look for the live broadcast chat. Right there, I'm highlighting right there. Sounds good, maybe a little low. All right, let me boost a couple knobs there and try to get that not to go crazy. Also, sometimes if I turn my head, of course, it's mic is right there. This is the chat, and you can look for the live broadcast chat channel, but you can see we've got a whole bunch of other channels as well, so go check those out too. This is the one where people are usually hanging out during a show. So hello to John Nodge and Andy Calloway, Todd Bott, Sam Blenny. Hello. Hey there, Liz. Hey, Starman, Tyeth. How's it going? So who else? Johnny Bergdahl. Many people. Hey, Paul Cutler. I think I saw C. Grover, Todd Bott, this cat right here. And hopefully I didn't miss your name. And then over in the YouTube, hi, Brent, our very own Brent, coming by to say hi. Dave Odessa, Devi, hello. Devi asks, is it possible to make a computer using only cheese? The answer is yes, but you probably want a more complete answer than that. And I leave that up to you, that journey. Hello, Dave Odessa. Hello, Ludovic Bouet says hi there. Sorry if my pronunciation is incorrect. Yeah, still, why does this not boost this? I'm turning knobs. All right, the gain. But here we go. Testing. Okay, there, that probably did the trick. Boy, that's touchy. All right, I'm gonna take a little off of that so I don't peak it, but yeah, we're a little louder there. So, what's happening here today? So I've got the usual things. If you're new, hello and welcome. If you don't know what the usual things are, I'll let you know. I've got a coupon code for you that you can use to save some money buying things over at the Adafruit shop. I've got a recap of my product pick of the week show from Tuesdays. I have a CircuitPython Parsec, pretty snazzy one, I think. I'm going to show you the progress on my HID keyboard reporter. And actually, I want to scroll up because I saw Tyeth mention something. Oh, is this how to mash 6 keys at once for some old school top-down GTA? Yeah, you could do that. Yes, so we'll be looking at the HID reporter based on originally the idea of San Blenny's X-input controller, but it has shifted its focus a bit more to HI key reports just because that's something that Limor was looking for testing during HID keyboard development stuff. And what else? I think, particularly if the microphone is working, I was going to maybe do this last week, but I think I might start this week. I wanted to dive into a little bit of some fundamentals of CAD and 2D and 3D design and modeling. It's something that I just do kind of behind the scenes when I'm building stuff or mocking things up or prototyping things, just to see how things will work, or for 3D printing or laser cutting. But I wanted to, if there's interest, and let me know in the chats what direction you want that to go, if any. But I'm gonna get into a little bit of just some basics of some 3D modeling, 2D design, and CAD. I'll be using Rhino, which is my preferred package for a lot of this kind of stuff, but pretty much everything I'll show will transfer to nearly any CAD or 3D modeling package you could use, such as Blender or SketchUp or Tinkercad or what have you, Fusion. Especially if there's enough interest and I go further into parametric design using Grasshopper, which I've shown on the show here a little bit sometimes, but that's what allows Rhino to have a lot of the more typical parametric design features that you find in fully featured CAD. So this can be a conversation between us and see what people are interested in, but I figure it's something that is useful for a lot of design work, fabrication, prototyping, building of things, so why not? Let's see, also I've got a busted LCD monitor I found on the curb that I want to pull apart and see if it'll work as a light source. I've seen some people do fake windows. I don't know if I have enough room to do one, but maybe temporarily I can put one in that case. But there's some cool reasons why a busted LCD with a working backlight and the many layers of lensing and diffusion works pretty well as a light source that seems a little more distant than it really is. So it can be used, people use them for light tables, for tracing stuff. People use them just as a light source for illumination, kind of a nice large light source that's slightly diffuse, or just to mimic having a window. So if nothing else, we'll pull it apart and have some fun doing that. And that'll probably be it. I think that's what I've got. So to start off with, a coupon code. So the coupon code for today is curbside. Curbside. That's not like homicide. That's more like I found something on the curb, or you have curbside pickup. So curbside, that's your coupon code for today, largely because that's a curbside find LCD panel that I'm going to pull apart. And you can use this in the Adafruit shop. Go to adafruit.com, go right there, to that place right there. That's adafruit.com. You can head up to products. You can head to new products by going to this drop down and then view all. Show you some of the cool stuff that we've got that's come out. And the latest info I've heard about this, I know I said something different a few weeks ago, but it actually changed. Pretty much anything that's a physical good you can get in the store, so not software, gift certificates, or subscriptions, but if it's a physical thing that gets put in a box and shipped to you, or an envelope, you can use the coupon code to get 10% off on that. It used to be there were some restrictions, I think, particularly with Raspberry Pi, but that has been lifted from what I'm told. So this right here, coupon code curbside, that will get you 10% off in the shop. And you just type that into the coupon code field on the way out. It'll slash the price for you right there. Additionally, if you have a bunch of stuff you want to buy all at one time, maybe you've been saving up for a big project or something, you can go to adafruit.com/free to see what our spend level enticements are. So if you spend $99 or more, it says it right down here, for orders of $99 or more, you get the free PCB coaster with your order. For $149 or more, you'll get a KB2040 microcontroller, which is a great microcontroller, super snazzy. I just used it in that Doom keyboard project the other day. It's a RP2040 chip on it, but it has some particularly cool features. It's a Pro Micro compatible pinout. It has Stemma QT out on it, and it's got direct access to the 5-volt and ground from the USB line, as well as D- D+ data lines, so really useful for things where you want it to act as a very low-profile keyboard controller or other HID device. For $199 or more, you'll get the coaster, the KB2040, and free continental UPS ground shipping in the US. And if you spend $299 or more, you'll get the coaster, the KB2040, the free continental shipping in the US, and a Circuit Playground Express board. So those are all things that you can get by spending bunches of money. We appreciate it. It's how the lights stay on here and keeps us in fresh, new working microphones. It's over here. So that is coupon code for today and some of the free enticements that we have. I just saw in the chat, Dave Odessa said, yeah, you have an impact driver on the workbench, some serious work lined up. At the moment, this is kind of like my only convenient electric screwdriver, motorized screwdriver. So I'm just going to use it to pull some screws out of that thing. Shouldn't require the impact settings on it, hopefully. Yeah, I used to have like a little cool screwdriver for pulling electronics apart, kind of a smaller scale one. It died on me, and I haven't replaced it, so that's what I'm using these days. Let's see, what else? Oh, someone said the audio is clipping every so often, so I'm just going to turn. Oh, yes? Is it cutting in and out? Please tell me. What is it? Hey, is it this silly thing? I'm going to touch it for a minute. Yeah, I did almost no, yeah, it could be a dodgy pot. I did almost no diagnostics on the microphone, but I replaced it. I'm happy to have two working mics, though, if that's the case. Yeah, cutting in and out, but I kind of jammed on that gain pot a little bit, and now I'm going to dare to touch a different pot to try to turn the main mixer setting down so I don't clip. Okay. All right. I think I'm going to swap the mixer. I have a different mixer I'll swap into here. Sounds like a bad pot, someone said it. Yeah, okay. All right. Cool, cool. Yeah, before next show, before Tuesday, in fact, right after this show, I'm going to switch out for a different mixer, audio interface mixer that I have. Oh boy, the joys of live streaming. So let's keep this show rolling. So I've got a Tuesday show, which is the Product Pick of the Week show, and this is the show where I pull something from the store and we put a big discount. This was a 50% off this week on this brand new Feather using the ESP32C6. Here is a little recap of the show. It is the ESP32C6 Feather, which gives us Wi-Fi, gives us BLE, Bluetooth 5, and 802.15.4 is Zigbee. And what makes that interesting is this is a cutting-edge board that may be useful if you want to do development for home automation using Matter. Have support for Arduino and CircuitPython. This chip does not have USB built on, so you can use the web workflows. I am sending data to it, even though it's not to a CircuitPy drive. And the way I'm doing that is from my browser. So you can see here I've got code.circuitpython.org. This is using a USB serial connection in this case, but you also have the option to do it over Wi-Fi or over Bluetooth. That's my product pick of the week this week. It is the ESP32C6 Feather. Whoa, hey, yeah, I'm sorry, I'm laughing because I was looking at the chat and someone said I never saw a TV I didn't like. You're gonna laugh because I brought a monitor and a TV home today from an alley and a different curb, and neither of them are that one. There were just a lot, and I saw them a couple days ago, and then they were getting like lawn sprinklered on, and I had to save them. So, but both of them were working, and I was gonna pull one apart, but I was like, I don't want to pull it apart if it's working. I have too many monitors, but this one is not. This one I will demonstrate to you how gloriously busted the LCD is and how cool it looks. Yeah, I need to get rid of some. I don't have a problem. Okay, next up, hey, let's do CircuitPython Parsec. Let me up a thing set up for that. I think this is a cool one. All right, this is a useful one. Here we go. CircuitPython Okay, there we are. Okay, so let me, yeah, that'll work right there. Let me, do I even need, yeah, so one second. I said I was set up, but I know I'm not. I need to bring up the terminal inside of here. And let's just go tool our way to glory. That's the cutie pie. Okay. For the CircuitPython Parsec today, I wanted to show you how you can get into bootloader mode without board access. So this is really helpful for cases where you have embedded your board inside of a project, such as that Doom keyboard project, and you have some buttons and things available, but you just don't have the ones that are right on the board. Most of our microcontroller boards that require a boot button and a reset button to be pressed, which includes the RP2040 and now the RP3050 boards, as well as I think some of the ESP32 boards. If you want to get to bootloader mode because you want to swap out, let's say, the version of CircuitPython that you're using, you kind of have to disassemble the thing to get to those buttons, unless you use a trick like this. So what you can see I've got going on is I'm importing microcontroller. And that means that I will have access to a couple commands here that I need. Microcontroller on next reset, and you can tell it to do something. In this case, microcontroller run mode UF2, and that is the bootloader mode that we want to get it into. And then also this is a command that uses essentially a command instead of a button to reset. So this is boot and this is reset in software essentially. And now all I'm doing to invoke those is I've created a digital I/O button, which I'm using for other stuff in the code. But during startup, before I get to the main loop, we do this. We check the button. If it's in false, which is with a pull-up resistor indicating that I'm pressing or holding the button, in this case it's a little switch that'll be flipped to the right, then let's wait a second and then check that it's still pressed. This way we don't just accidentally hit it, but we have to intentionally hold it down. Then we're going to print, we're going into bootloader mode, and that's just for demonstration purposes so that we can see this. Then we'll sleep a second, and then we'll actually run these two commands, which will put my board into bootloader mode. Then the main loop will only run when we're functioning normally, and you can see I'm still using this button, and I'm using it to say, hi, the button's pressed. Right here I flipped it over, button is pressed. We're just innocent men. Or button not pressed. We're just normal men. That's fine. So what I'm going to do now, actually, let me add one screen here. I forgot to do this because I want you to see a Finder window, which is where you'll see that I'm actually in bootloader mode. So let's go right here and add a new screen capture. Sorry, one second. It'll go into black hole mode, but let's pick a window that is a Finder. There you are. I think that's the one. Is that the Finder window? Did it show up? I don't see you. Let's try a different, okay, let me point it at a different Finder window, sorry. Configure. Nah, there it is. That was just the Finder itself. Okay, getting closer, but it's displaying a little weird. How can I get... That's just some piece of the desktop. That's no good. All right, let me delete that one and try a fresh one. Pointed at the right thing from the beginning. Okay. Through the miracle of editing, this will actually be all put together in one place for the CircuitPython Parsec that we repost. Okay, so let me say window, configure, Finder, where are you? There. This is the time. This is when it's going to work. Is it? Oh no, it won't work. Let's see. You know what? I'll just do the full screen. You'll see the whole screen. Let's just do monitor. Let's see it here. Good. So this is what we care about right here. And let's see if I can zoom this and crop it a bit. We have ways. Crop. Sure, that'll do it. Okay. So now what you can see is in my Finder window right now, I have this as the CircuitPy drive. In bootloader mode, it should show up as RP2, RPi, or whatever it is for a Raspberry Pi Pico. So what I'll do is I'm going to unplug. Oh, you can't see it. Hold on. Thank you. Let me push that up there. Okay. Thanks for that note. Perfect timing. Yeah, that doesn't new items don't automatically go into the broadcast. Probably for good reason. Okay, so what you can see is in the Finder window here, I have my computer's hard drive, a RAID array. Here's the CircuitPy drive. So what I'm going to do is I'm going to unplug the QtPy, and then I'm going to flip this into that virtual sort of boot mode. Oh, good! I made the Finder go away. Come back, Finder. That's what happens when you unplug a device while it's selected. So let me try that demo again. Okay, so when I plug this back in, I'm going to put this into this bootloader mode that this code is looking for, and when I plug it in now, that's the bit of code that's going to run. It just said in my output, going to do the restart now, and now it's showing up as RPI RP2. That is the boot drive that we can go and drag a new CircuitPython UF2 onto, or whatever it is you need to do. If I doesn't matter what I do at this point, it needs to be restarted. So in this case, I would just unplug it, plug it back in, and with that switch flipped to the left, it's showing up as the CircuitPy drive. It's doing all of the same stuff it was doing before. I'll hide this now, and you can see it's back to normal, right? So this is how you can use a button that you're using for some other thing in your code to invoke a boot and reset inside of CircuitPython when you don't have access to the board itself. And that is your CircuitPython Parsec. All right. Sorry for the shenanigans there. Let me tell you, let me ask you, were you able to see, hopefully you could see that in the end after I pushed it over. You said we never saw a Finder window, huh? Okay, let me figure out how to force that to work. I'm surprised that that didn't happen. I think I even saw it in my preview of what was going on, so that's weird. Oh, you did get it. Okay, I think I'm a little time offset from what I see in the chat. Shoo! Okay. That's weird though. Why would it? But thanks to, once again, Todd Bott, who's a great source of these kind of tips. He's been building a lot of little synthesizers and things where you kind of bury the microcontroller away. And the ability to do this without opening the whole thing back up is pretty helpful. Oh, and Sam Blenny was telling me my audio went in and out again too, which is interesting because I don't think I touched anything to do with the mixer. I'm so sorry, folks. My apologies that I've got glitchy audio. It's entirely possible that it's my transmitter pack, although I'm wiggling it around and it's not having problems. All right, well, I'll definitely try a new mixer and do some more diagnosis during the next day or two before I go and broadcast again. All right, I'm just going to keep an eye on the VU meter here for a second while I do stuff. I'm moving. Hey, look at me moving. My one concern is that it wasn't the mic, but the jack on the mobile pack. If that thing is having the problem, it won't matter what mic I put into it. I'm wiggling in it, it's not doing anything. Okay, yeah, maybe it's that mixer. Okay, sorry, let's move forward. So next up, hey, let's take a look at this project. I showed this on Show and Tell last night, and I showed the early stages of it last week. But I've got it a little more refined, and we can take a look at the code behind this. So I'm gonna set this little feather and this super awesome keyboard I borrowed from one of my daughters. Let's go to, let's say, a view about like that, and I'll fix that focus for you. And let's just take a look at it on its own for a moment, and then we'll take a look at the code. So what we've got here is a Feather ESP32S2 TFT and a Feather doubler with the Max 3421E USB host chip. So this can host a USB device, such as the keyboard. And then you can see on my display here, it says HID reporter unmounted. So I'm going to take this keyboard, plug it in. As I mentioned yesterday, often this doesn't want to actually reconnect on its own without hitting reset, which is just kind of the nature of that chip and that board that we have there. But in this case, you can see with a reset, using the reset button on the board, we get HID reporter, and then we get the vendor ID for this board and a product ID for this board. And then if I go and press keys on the keyboard, here's the up arrow, right, down, left, there. I can see the 8-bit hex codes for that keyboard press. If I press left and up and right and down, you can see we're sort of stacking up those keys. And everything is good up to 6, then it sends like a double byte thing for the N key rollover or whatever. I don't understand the details of that. But what Lamore was really looking for was just something where she can see what hex code is being sent by a keyboard device, or if you're developing something that's acting like a keyboard, is it sending the one that you expect? What hex code is it sending? So, for example, great question. Sam Blenny says, what about shift or control key combos? So you'll notice if I press the control key, it's actually sending a 1. That's the left side of the keyboard control key. If I press the right side of the keyboard control key, that's a 10 in the first bit slot there. So Control Z for undo, well, a Z is 1D and Control is 1, and press them together, you just see both of them show up. So typically there are not unique codes for the key and the modifier. It's just up to your operating system to do something with the fact that it got the Control key and the Z key showing up. So that's the way the modifier keys work. If I press the function key, it acts a little differently. Function key, I think, is actually a product of the keyboard microcontroller. And you often see this in cases where we've got all these function keys that are condensed on this keyboard to be a reuse of the number keys, that top row. So there is no separate function key row. Also, you'll see cases where here's a keyboard that has a function key row, but there's still a function button, and that allows you to use those buttons as like media control. So often F12 for volume up and F11 for volume down, you can hold function and get back to using F11 and F12 or vice versa, depending on how you set it up. So yeah, if you look here, when I press function, I don't see anything happen. When I press function and the 1 key, it sends 3A hex code. If I just press 1 on its own, it's 1E. So that is a case where the keyboard is actually coming up with some other hex code to send. So Sam Blenny also posted over in our Discord chat a nice link to HID codes in a USB spec file, so you can check those out there. So yeah, most keys here you'll see, here's the escape key, it's 29, 1, 2, 3, 4, 5, 6, and so on. If I press 6 of those, I'll get 6 different keys pressed. If I go to the 7th key, this is not the full answer. It's sending 2 bytes, and I'm just hiding the second one off the screen there. That was just mostly out of convenience for using the display that I have there, and Lamore's request was she just wanted to see 6 of them, so I'm keeping it simple. You could modify the code if you wanted to scroll this or shrink the typeface down or something, but I wanted something legible. 1 second, too. I just want to get the serial monitor closed so we can look at some stuff in the serial monitor in a second. So let's see, what else? Yeah, I think all the keys on here you're going to see, other than function, even Windows key, which sometimes is just the GUI key or the Apple key, they will all sort of send the same thing. And then it's up to your computer to know what to do with the Z key and the Command or Windows key. Shift, again, left side, right side are different, a 2 and a 20. It's also interesting that these modifiers occupy the first bit, where most keys are on the third, starting on the third. And I don't know if anything shows up in the second bit. So code for this, let's jump over to Arduino. Find you, little Arduino, where are you? So this is a tiny USB dual mode based code library. So if you have tiny USB in Arduino, you can just go to examples, tiny USB or Adafruit tiny USB, dual mode, and let me check which exact one. You won't see this screen that I'm looking at. So examples, tiny USB, where are you? There you are. Dual roll, sorry, not dual mode, dual roll. And then there's a serial host bridge example. There are 4 HID examples. There's a device report, a mouse log filter, a mouse tremor filter, and a remapper. And then there's a mass storage example and a simple example. So I think I was using a HID device report code, and then I mostly added to it just the display stuff. So that code already spat out to the serial monitor. In fact, if I open up serial monitor, oh, let me unplug. My cutie pie was over there. Yeah, I don't even have this Arduino plugged in. What am I doing? Or this feather. Let's plug in this feather. I have a battery under there, which is why it's on. And let me reselect the serial port. Good. Let's see if this behaves. Okay, yeah. So it's actually, that's a little small and probably harder to read. I can't remember how to make that bigger. I don't want to mess it up. But the same, that little HID report, it's the same thing that I'm printing on my screen there, and I'm just splitting it up into 2 and 2 to make it fit. If you look here when I get to that 7th key, that mess there is what we get. So I didn't want to deal with that. It's long, actually. What is it, 3 bytes? It might be 3 bytes long. If anyone understands why that works that way, please let us know. 2 bytes or 2 messages? Don't know, Gordy G. Do not know. I think the serial output will list when the HID device is unplugged. For some reason, there's 4 instances there. I'm not sure if that's because we've got MIDI and HID and storage and something else. That might be this 4 mount points or whatever they're called. Let's see if this one will find itself when I plug it back in. Sometimes it does, sometimes it doesn't. Yeah, it didn't in this case. There it is, it's mounted. If I unplug this and grab a different keyboard, so this is a split key keyboard I made a couple years ago using a KB2040, and this will also work for this type of thing. In fact, I'm going to steal this USB cable. Can I? Yeah, I'm going to steal that USB cable because the one I have on here is very short. Oh, you know what? No, that'll work. Let me leave that plugged in. Endpoints, they're called. Thank you, Gordy. Endpoints, not mount points. Okay, so I'll get this cool pink USB cable out of here. Oh, you know what? I'm moving around a bunch. Did my audio go? No, it's still there. Amazing. All right. Maybe it's the mixer. Could be the mixer. Okay, so let's plug in. Oh, and see, that one showed up without a reset. In fact, I feel like this is something I noticed before when I was doing the HID USB host stuff, is the same device unplugged and replugged doesn't show up. You have to reset, but a new device does show up. Not sure why. So you can see here, this is a different vendor ID and PID. For some reason, and I didn't check to see what code I have running on here right now. I can't remember if it's QMK or KMK. For some reason, it's always showing the control key is pressed. And I can't remember if I made a toggle for that or something. But it looks like it thinks the control key is always pressed. This is the layers. So anyway, could be useful for troubleshooting stuff if you're, like, hey, what's this key actually doing? Why is this hex value mapped to that button? Todd says, byte 0 is modifier keys. Byte 1 is always reserved. Bytes 2 to 7 are key codes. Thank you, they're bytes, not bits, that are expressed in hex in this case. So yeah, so there you go. So there's a different device, and I think, I don't know why that Z key doesn't show up. If I rise to a different layer, does it? No, I can't remember. I can't remember what I have this thing thinking it's doing. Yeah, I don't remember how to use this at all. I haven't been using it. There you go. Okay, so that's the state of that. The code is up. If you want to grab this and try it out, it's kind of neat because it just requires a feather, the regular TFT, not the reverse, feather ESP32S2. It It'll probably work on a S3 as well. And this host Featherwing. You can do this stuff also with a RP2040 and a PIO host. I didn't try it, and so I don't have that in the code, but if you look at the dual role example, it basically says either you're doing this with PIOs on an RP2040 or you're doing this with the Max 3421E. I used that since we have this as a breakout, and I had this this TFT feather to show that. Okay, yeah, and so there's a link if you're interested in this stuff. There's some conversation over in the chat about how this stuff works. Toddbot posted here. osdev.org shows the report format and how that is encoded. Oh, cool. Sam Blenny also said that they've done some CircuitPython code instead of Arduino to do HID reports on a numpad. Excellent. I'll check that out for sure. And I might post both in the Learn Guide so that people can find that, as well as Sam's original for gamepads, which I'm not doing here. All right. How we doing? Why don't we dive into let me show the link here. Thanks, Sam. Let me show this real quick. So, Pumpkin Numpad Tester from Sam Blenny. Sorry, it's a little cut off there. So here's some code that is reading a numpad through USB host in CircuitPython using the same, almost the same setup. He's got the S3 TFT feather and the Max 3421E Featherwing on a doubler. It's a nice format. One of the other interesting things that I've noticed plugging different keyboards in is a lot of keyboards aren't a keyboard. They're a hub. They're a USB hub with an internal hub key and then a couple of... So a Raspberry Pi, I've got that standard official Raspberry Pi keyboard. That won't show up here because that thing's actually showing up as a hub. It won't show up as a keyboard. It's sort of a layer removed from actually being a keyboard as far as this host is concerned. Yeah, so thanks for posting that, Sam. Very cool. Agreed. All right, let's jump over here. Let's go to the workbench. And, oh, look, that camera went out. These are my main gremlins, as you probably know these days, which is my camera that overheats over here. And oh, why is that looking so dark over there, too? Oh, here, let me spin this big light around. That's better. Yeah. My mixer and my camera. Kind of critical things for what I'm doing here. All right, let's jump over there and take a look at this thing. So this thing's pretty cool. It's a LG curved 32-inch display. You can see the problem right there, this impact it took. This thing maybe was pretty new when someone murdered it because it's still got some of the plastic film you might have noticed on the LG logo back here. That's still sitting there. So this was in the alley by the dumpster at a computer repair place is where I picked it up from. So I knew it had problems, but you can see that's the key thing right there. And in fact, the one inconvenient thing about this, it has a DC power plug, which is neat, but it goes into the back, so you can't lay this thing on its back. It has to be on a stand or whatever. So in a second here, let me grab a HDMI cable. This will do. And I'll just plug in a source. I have, from CircuitPython Day, I have a little DVI feather. So we'll go into HDMI 1. This will be upside down for that front camera, basically. Turn it on. I hear it booting up. There we go. So there's the problem there. You see that? It looks pretty cool, actually. The liquid crystal got very murdered there. There's basically no repairing that other than replacing it. I think this was $200 new or less, so it's probably not worth trying to save, as much as that pains me. So it gets to be our donor for exploring using the backlight. So that's just proof that I'm not a monster. And so let's unplug that. I have not pulled this one apart. This will be the first time, so who knows what we'll encounter. Hopefully it's not like a really bad case of needing to heat up glue or something like that. We'll just, we'll see. These are the Visa mount screws, which probably aren't really holding the case together at all, but I'll take them out because they would be in the way, I think. And I think this is going to be, okay, so there's a couple of arrows pointing at spots where I suspect you're meant to pry it open. So let's try at first with a little plastic spudger, which may get under there. Yeah, I hear a little clip, I think, releasing. It's wiggling a little, so sometimes these work. I'm sorry, I know you can't see that. Let me put this off the edge a bit. Hopefully it doesn't fall. And see. Let's try a little guitar pick style thing. I'm not encountering anything clip-wise over there. Let's try this way. Nothing there. Huh. Oh. I'm not sure if I just flipped a clip or just broke the little guitar pick that I have, but let me get, we're upgrading to metal spudger here. Where did I put it? Oh, here's a nice, actually, let's try this one. This is a nice plastic one as well. Oh. Do they really want you to get in deep there? Seems like maybe. Sorry, I've got to pull this off the edge so I can get leverage. Okay, that's a good sound. And honestly, I could be real violent with this. I don't actually plan to keep the case. If I end up using this as like a little light box, I won't need any of the case. This one's weird because it's curved. That wasn't one of my criteria for this. It was just the one that I found that was broken. Yes, these are just releasing a bunch of plastic clips. Usually it means you're releasing them. Sometimes it means you're just breaking them. But I think these are actually releasing. Can depend on how old the plastic is and how much time it sat out in the sun. Let's see if we can see anything in there. Probably not. Yeah, so curved doesn't really help us, although I suspect when we get to the panel itself, we may be dealing with stuff that is flexible enough to just flatten out. The light panel, that is. All right, let's flip this over. All right, that's a good sign. That's going to be hard. I think we have to start from the little insertion point there to get into this guy. Whoop. Hope not to impale myself on a spudger. This one's a pain. Where is... Oh, that's another... Oh, look, I have 3 of these. That's helpful. These are from the... I think all these are from iFixit, different iFixit kits I've had over the years. Come on. Yeah, I kind of wish I had a metal one, but I seem to have lost them all. Oh, that popped. It heard me. This couldn't be more awkward the way I'm trying to do this for the camera. There we go. Okay. Oh, gotta come down this way now. I think we're getting close. Whew! Why would it kill them to just use some screws? Oh my God. Oh my God, yeah, it's just 100 plastic clips. All right, goodbye to that thing. And now what are we looking at? Let's have a look there. Okay, so we got some speakers, we got the controller board. Let's start pulling stuff. I have never done this. I've repurposed displays out of their frames to make them thin, to take them just out of their bezels and stuff like that, all their housing, but I've not gotten rid of the main controller and the main LCD. But generally, from what I know, you don't need much because you're just going to light up the LED strips that run around the perimeter, most likely. This is a fairly new display, so I doubt it's a compact fluorescent. You can unplug some of these speakers and things to maybe reuse. Let's see, that might have been a power... That could have been a power to, next time use the angle grinder, says Andy Calloway. That could be power to the panel right there. Let me zoom in a bit while I'm doing this. That could be power for the LED. This is the button, a little joysticky kind of 5-way button down here. That's kind of neat. It'd be fun to reuse that. I'm just going to leave that there for now. Here's speaker. I'll leave those since I can take them out with this. Here's the data to the video panel, presumably. And here's another screw. Here's another, presumably, power to the LEDs. It's maybe 2 strips. So it could be worth finding out, putting a meter on those, what voltage those are running at. So I'll leave that mostly intact so I could run it again. But interesting, I don't run into these displays very often that just use a DC external supply like this one. This is, what is this? A 19 volt, 3 amp, 3.42 amp switching adapter. Nice, that's a neat adapter. Okay, so next let's pull all of these. One thing I've seen some people do is replace the LED strips that are around the edges with new strips that are 12 volt LED strips with a little adhesive backing, just so they don't have some weird voltage to work with. You could presumably do a NeoPixel strip and run some color through it. That might be fun. Okay. So what do we have now? This looks like it mostly just lifts away. Okay, I can zoom out a bit so you can see what I'm working on, sorry. Right there. So that's that little border. And now, I don't have a bit for this small enough, so let's use... now we're in the land of some electrician's tape and some cloth tape hiding some of these cables, as well as some screws in the edges that are holding in a lot of this metal backing. So I just want to get rid of as much of this as I can. Interestingly, there's some metal posts built into this to presumably gain purchase on the plastic housing I just got rid of, since there's no screws into that from the back. And like I said, loads of fun to pull something like this open when you don't actually plan on putting it back together, because you don't have to really keep track of your screws placement. Okay. That connector. 2 more screws here. Everyone wants an angle grinder to come out. Uniscu 7 too. Oh, look, there's the main, maybe the main video driver. And I'm guessing this initial thing is like power supply and video format and audio conversion here. That am I going to ignore? Pull that, goodbye. Please, goodbye. John Nodge says DC is fairly typical for a computer monitor, right? Oh, maybe you're right. Maybe I've just been dealing with TVs more that are using just like a AC plug. Okay, that's just stuck on there. I'm gonna peel off these ribbon cables that I think are the LED strip power. And move some stuff so I can show you that. So those will go right there. And I might need those. I'm just going to flip this here. So this is, I think, one of the connectors for the LED strip that runs around it here. Looks like a little right angle PCB connection right there. I'll leave that. I don't want to break that. If I can, I'll leave. Oh no, you know what? I'll need to pull that to get this frame off. So let's see how this comes off. Let's get a little flat head to lift that. There we go. All right, so there's another one over there we'll take off. Came off a little nicer. And some of this stuff, I think, isn't just for holding it on, but for preventing light leak, because I think the LED wants to spill out right there, and if the case has a hole in it, you'll get a nice bright spot on your wall. So I imagine some of those decisions are made in testing and not initial design. So the black one, nice thing is I have video of this. The black one was the one down here, red was over here, probably no difference, but okay, and then these I think pry off. I think this is like a little plastic surround. Let's take a look the other side. Yeah, so now we're looking at kind of the cover, so plastic cover and this little bezel strip at the bottom. Let's see if we can get those off. Oh, look, more screws. Oh, John said that their monitor they're watching on has AC, so there's clearly no rule. Yeah, I guess if you're trying to go thin, you don't want the power transformer inside of it. So this is some space saved here. Is that all that holds this in? Yeah. All right. Hey, look. Whoa, what's all this? This is way more components than I was expecting to live down here. What are you? Can you see all this? Oh, I should have brought a magnifier. Let's see. Is it the same brand on here, LUO or AUO, as the main controller? I'm going to assume this is part of the LCD display. I don't know if it uses like a mask, like a LCD mask. You can see it looks like it's heading to sections. It's a bunch of ribbon cables here. I don't know a lot about how this would have been set up to drive video, but again, I don't think that's anything to do with what we're really using this for. So let's see. Brightness control, yeah, I think maybe like LCD shutter over the thing to adjust brightness, but in regions, could be. All right, so where are we at? Got a bunch of clips here. Let's pop these. Fascinating. Okay, there's like a beefier connection here at the corner. Let's see how that comes out. Right here. So this has been these little clips up to here. There we go. Yeah, this is like a plastic as well, so it's pretty. Oh, we've got a little more tape. Let me cut around the perimeter of this before I try to pop that off. There's just a few pieces of. And then Todd says he didn't know there were non-DC desk monitors. So we have all possibilities represented. Not a lot to grab onto. I'm trying to balance it up here. This is thin. All right, so I'm going to leave some spudgers behind here to get those to stay in place. There we go. There's one. I need some new guitar picks. There we go. Okay, we're getting there. Okay, I'm starting to see some of the layers. That's cool. Okay. Yes, yes. This thing is so huge and unruly. All right, now flip it around so I can pop that side off. But what I'm seeing inside now are, because we don't really care about the LCD, which is this front piece and all these control boards. What we care about is the diffuser, the Fresnel lens, another diffuser, some acrylic that's edge lit. That's all the stuff we're trying to use here. I abuse this knife a little bit, it's true. Is that the tape holding that in? This is good tape, whatever this is. Okay. I just need a thinner knife to get between that. Woo! Okay, let's flip it on its back and pull away the LCD. Okay, so that's the broken bit. Further broken now by my all bending on that, but that was the actual panel pixels. You can see that that was the original crack right there, where I think got zapped. I just want to make sure I don't get any glass. That could be, oh, it looks like it's still under a laminated layer, but I don't want to get injured by that. So I'm going to move that aside. Okay, and now we're left with this. So this is a sandwich here of diffusion layer here. Let's see. The next layer is a Fresnel lens that helps this seem like a broader light source than it is, evens it out. And then here's an acrylic panel. This should be our final layer, and then just a white backing. Yeah, so this acrylic panel is what's getting edge lit. Let me move all this for a second. Try to avoid scratching that stuff. Not that it's critical. But yeah, so this is like a background layer. Maybe I should have left that under there. Let's get that out too. So just try to get as much white light pointed forward. And how about that? This thing only has one LED strip down at the bottom. So you can see here, it's these guys right here. There are two strips. They each had their little connectors here and here. So if we can light those up, then this thing basically works. That's the magic of the thing. Might as well see if we can run it off of the original board. So on the original power board, we just had these two connectors here and here. There's every chance that this won't work now that I've pulled so much of it apart. It may run tests that fail and stuff like that, but I'd say it's worth a shot. And I think this was to that side. And this was that side, in case they're differently polarized. Who knows? Maybe I'll try to light just one of them in case I blow something up and ruin it. I doubt these would be in series for their voltage level. So if you have anything to scream at me right now, let me know. I'm going to check the chat. Oh, someone said, Andy Callie says it's fun to shoot lasers through those Fresnel diffusers. Okay, so let's plug this in like so. And I'm gonna plug my button, which I never extracted from the back of the case. Let's see if I can, because it's required to power on. Where'd it go? Button. Oh, it's on the middle bezel. There it is. So here's the power button. Rather than try to extract that from a million plastic clips right now, I'm just going to plug it in. The controller like so. All right, and now let's see if under the unlikely case that this thing manages to not just throw a million errors because nothing's actually hooked up, see what happens. Stay clear of all metal objects. Plug in our hey, it went bing and the light lit up and it definitely didn't light up the LED strip. Okay, we may have to supply our own juice. That's fine. I could probably reconnect this. Yeah, I think it went into auto shutdown. So let's unplug it. I can probably reconnect the one main controller here, this guy, right? How was that one in? Oh no, wait, which one went into? It was not that one, was it? That to there. Oh yeah, there's a single connection. Did I drop that ribbon cable over here? It's a smaller one. Are you under there? No. I need a bigger workbench for this thing. Let's see. Not those, not that. Hey, cool. I have every ribbon cable I need except for the one that would actually fit there. That wasn't attached to something, was it? Yeah, I don't think I'll be able to trick it without that. I'll have to review my tape and see my video and see where did I put that. So I don't think it's anywhere obvious anymore. Sorry about that. Okay, but that may be a good stopping point because I want to measure that output of. Oh, that camera just died too. Okay, and that's a great time to switch out of this. I'll flip that camera off. Come back over here. That might be a good, that might be a good spot to pause. Oh, look, there's the ribbon cable. Right there. See, it's a good thing I came over to this side of the bench. All right, I'm willing to try that actually. Let's. I'll leave this camera. Can I put this camera in the corner? Yeah. You probably won't see me. Yeah, you might see me in there. Okay, so let me just on the off chance that it wants to find that on connection. So that. I think is like that, yeah. And if I had to also hook up those bezel mounted or the LCD mounted 2 ribbons, we could go there. I won't do that here now. But this basically went in here, I think in this direction. So maybe if this controller is hooked up during the power on self-test, it'll agree to light up our backlight. Shall we? All right, let's try it. Aha! We have light, okay. You won't be able to see, I mean, it's just gonna be whoo bright, but all right, let's throw some, I'll leave the, since it's a pain to wire it to over there, we'll just do half of this. That might actually look interesting too. So let's throw the layers in. Okay, so this is the edge lit acrylic. Oh, it just turned itself off because I had no source. I should plug like HDMI into there. Okay, so now you can see like this is a very impressive, if I cover that, this is impressively even. I don't know if I can adjust my Exposure here, no, it's not in that mode. But just setting down this piece of acrylic, it just is super even. It's amazing. There's only one row of LEDs. Usually these, I thought, had them on both sides. So now we'll put on the Fresnel layer. And boy howdy, does that look nice, nice and even. Turn it back on. Let's see, what's the difference between that layer and this one? It's a similar, I don't know, maybe they had, yeah, I don't know what the difference is, but this is a very similar type of lens. Maybe they just want 2 layers, and then this is a diffusion. So, as you can see over in the corner, I'm super well lit by this. Over in that corner view, if I turn this off and on, will it go off? Yeah, I'll just unplug it. So, boop, and oh, now it doesn't want it. There we go. I think I have to hold it a little. Yeah, pretty cool. I'll try that camera one more time just to see if that'll. One's vertical and one horizontal. Thank you, Andy. Okay, yeah, I think these used to be more like a circular one instead of 2 layers of vertical and horizontal. At least that's something I thought I remembered. Yes, Dave Odessa, polarizing. Yeah, one sort of polarizing vertically, one horizontally. Let's switch the camera back over here. This one, okay, yeah, it just turned itself off. You might have seen that. Focus that and see, does this one have, yeah, okay, I can darken this one enough. This might look good. Put this in the corner here. Zoom that out. Yeah, so this is cool. You can see it over in this view. Just half of this panel, kind of quality of light that gives. The curve probably doesn't do much. It's not that much of a curve. It's not like going to wrap the light around, but it's sort of interesting. Doesn't have to be the way this is done, but it's convenient. I don't think I'd get rid of that. But you can see this thing is tiny. Super thin little panel. Kind of fun to have half of that on, half of that off. Some of those polarizing Fresnel-y kind of layers. Come back on. There we go. So maybe I'll build a window, a weird window in the wall here with this, or who knows what. I don't know if these are any good for like doing backlight posters and that kind of thing. But here it is. We have it now, and it's actually a little more useful than it was before because of that broken LCD. So I think I'll keep this and try to do something interesting with it. All right, let's power this off. And we can switch back over there. And I think that's kind of a nice way to do that, is keep the main board and driver for the display and all that, just because even though I'm using none of it, it means that the power button still works and the voltage for driving the LEDs is there. Could be that it's a pain in the neck because of the auto off and stuff like that, so I may just end up driving it directly. We'll see. Gordy G, is the LED strip flexible? Is the LED strip flexible so you can straighten it? Yeah, it's just a piece of tape. I think it's on a. Oh no, you know what? Is it curved? It might be a curved PCB, in fact. I can't tell from here. Yeah, that may be slightly curved to fit because it looks like it has a nice radius with the thing. So maybe straightening it wouldn't be worth the effort. I mean, there's just a lot of what's there that's helpful, but depending on the use, you could just get other LEDs, other edge-lit LEDs strip to light it up, or maybe going to NeoPixels would be fun. So maybe I'll do that. We'll see. Yeah, need to check the voltage. It could be just easier to drive it with. It's possible that is just driving it at 12 volts or something like that. I don't know what it's sending. All right. Well, thanks for coming along on that journey. Oh my gosh, are we over on time? Yeah, that's what happens when I don't pre-cook it like a cooking show. So we'll come back to my idea of doing some CAD stuff next week. I don't want to run any longer. Let you go. Oh my gosh, thanks for anyone who stuck around through the whole thing. At least it was worth getting the thing to light up at the end, I think. Gordon G says, get a 555 timer to tickle that input button just to keep the light on. I like that idea. Okay, before I go, I will remind you, curbside, that's where all my good stuff comes from, is alleys and dumpsters. But curbside is also a way for you to save some money. You can go to adafruit.com and check out with a whole bunch of fun stuff in your cart. And when you do so, type in curbside as your coupon code to get 10% off of your order. I think that's going to do it. I'll get out of here. I believe Scott is going to be on the deep dive tomorrow. Deep dive with Scott tomorrow. Check and see. We may also have a foamy guy over the weekend, a Desca Lady Ada, then back on to all kinds of fun stuff starting again on Tuesday with our live shows. I'll be hosting a show and tell next week on Wednesday, so if you want to come by and show some things and chat about them, please do. Yes, some nice thanks. Very illuminating show. I appreciate it. Love the puns. Thanks, everyone. Thanks for stopping by over in our YouTube chat and our Discord chat, as well as just watching. If you're off there watching without any chatting, that's fine too. Thanks, everyone, for Adafruit. Bye.